Welcome back, everybody. We are getting ready for our first set of notes in Unit 5. So go ahead and flip to your table of contents for Unit 5. We are going to put these notes on page 43. And the title of these notes will be Key Features of Quadratics. Key Features of Quadratics. Once you have that written down, you should have the set of notes. They look like this. You either were given them in class, or maybe you had to print them off, but whichever, you will need to fold this in half and tape it down on page 43. So go ahead and get that done now, and then push play when you're done. Okay, now that we have these taped down, we're going to go ahead and start. So, quadratic functions. Weird name, but they're pretty simple functions. They actually act a lot like absolute value functions. So, let's talk about what they look like first. So, the quadratic graph, it is a U-shaped graph. So, one way it could look is just your traditional U, that's right side up. The other way would be an upside down U. These are what they always look like. They're never going to be on their sides. They're always going to look like this. Okay? Now, what we're going to do for this little section right here is we are going to graph the parent function. So, this is our equation for the parent function. So, I want you to remember when I talk about parent functions, I'm talking about the very first graph of the functions that look like this. So, think about it as like the original function, or the OG one. This one was the very first quadratic graph that was ever thought of, okay? So, this is the XY table that we're going to use. We need to input these X values, get out Y values, and these are going to be the ordered pairs that we will graph. So, I'm going to do the plugging in part for you. I just need you to listen to me and kind of follow along. So, we're going to take these X values and substitute it into this equation right here. But remember, anytime you substitute, it always needs to be in parentheses. So, I'm going to take that -2. And I'm going to substitute it in. Well, now I want you to keep in mind that that squared, all that means is that we are taking -2 and we are multiplying it by itself that many times. So this squared is actually saying -2 times -2, which is +4. So that's what's going to be my first Y value. And then you just continue on. So I'm going to go a little bit faster now. So I've got -1 squared. That's the same as -1 times -1, which is +1. Okay? Keep on moving. The next one is 0 squared. That's the same as 0 times 0, which is 0. Next is 1 squared. That's the same as 1 times 1, which is just 1. And then the last one is 2 squared. So that's going to be 2 times 2, which is 4. And there we go. So here's the math behind the XY table. This is the math behind these Y values. So now we have 5 ordered pairs that we can actually graph on this coordinate plane. Now, before we actually graph, I want you to notice the pattern that's happening in our Y value column. So if we look right here, this 0 is kind of in the middle, and it's the same number on either side of the 0. That's the symmetric quality that a U-shaped graph has, like the idea that this side is the same as this side. So, what I want you to do, take you like 5 seconds or so and graph these ordered pairs, okay? A quick reminder on graphing ordered pairs, your X value is on your X axis, so if we're going to graph -2, 4, we're going to have to go over to -2 and then up to the Y value of 4. Just keep that in mind. Your X value comes first, then Y value. So go ahead and finish graphing these. I'll do the same. So you should have them graphed by now. So now we just have 5 dots on the graph. And when you first look at them, they kind of look like a V. So your job, knowing that this is a quadratic graph and knowing that it should look like a U, your job is to make this look like a U. So we're going to have to round out the bottom a little bit more. So how you can do that is focus on the bottom 3 dots kind of round out the bottom, just like that, and then continue these sides and grab that top dot. If you start graphing them like this, it teaches you how they should look, so that way when you get better at them, you don't have to draw them this way. But that's how I started drawing them. And there's our graph. Make sure you add arrows at the end. Remember that means it goes on forever. And there you are. So this was the very first quadratic graph. It's centered at the origin, the middle of the graph. It's very simple, a good width apart. This was our original graph. Now what I want to do with you guys is talk about the key features about this graph. So the very first one, and it's always the most important point on a graph like this, it's the vertex. So I want you to, in your notes, make a little note that this is your vertex. It's the very middle of the graph. And we can put middle of the U. Okay, or it could be upside down. Just remember, it's still the middle of the U. So when it asks for the vertex, that's asking for the ordered pair. So the ordered pair of that spot is 0, 0, because it's at the origin. The next one that we have to answer is maximum or minimum. So this vertex right here is going to be a minimum value because it's at the bottom of the graph. So I tell my students that if it looks like a bowl, because this one kind of looks like a bowl, it's rounded on the bottom, and this is the bottom of the bowl, then this is going to be a minimum value. Now, to be a maximum, this is what I tell my students. If it's a maximum, remember, it's going to be upside down, because this vertex right here is like the top of the mountain, and that's the max height of that mountain. So just be careful. It depends on how it opens, which is actually our next question. So the direction of opening is going to be up for this one. I want to come back to axis of symmetry, so we're going to skip down to the zeros first, and then we'll come back. So the zeros, make a little note here. The zeros are the points where the graph intersects the x-axis. So the zeros are the points where the graph intersects the x-axis. So when I look at this graph, I'm looking at the x-axis, which is this one. The x-axis is normally a little bit more bold than all of the other lines. So we're looking at this line right here. All I'm looking for is, does that graph touch the x-axis at all? And it does. It touches it one time, and it's right here. And this number is 0. So the 0 for this one is 0. Now normally, keep in mind, normally the vertex is not at the origin, so it's not always going to be 0. Okay. So now let's backtrack and get axis of symmetry. So if I were to take a piece of paper just like this, or this little post-it note, and I were to fold it in half and then open it back up, it would be symmetric because it would be the same on both sides. Same idea here. The axis of symmetry is the line that we would use to fold that graph in half. So I want you to take a highlighter, and I want you to highlight the line of where we would fold this graph to cut it in half, or the middle of the graph. If I were to fold this graph on this pink dashed line that I just drew, that would cut that graph in half, and then they would match on each side. So that axis of symmetry is this pink line. So the equation of that pink line is going to be x equals, and then whatever number it's sitting at. So this is the x value of 0. So my axis of symmetry is 0 for this one. Okay? Keep in mind it's not always 0 because the graph is going to be moved around. All right, and the last two that we have is domain and range. So I want you to remember domain is x values, range is y values. So when I talk about domain, I am talking about the x-axis right here. Our job is to figure out what x values are used to create this graph. So we for sure are going to use all of these because I can see my graph. But let's look at the left side first and see if that's the only ones that we use. So this x-axis is going to continue on forever. That's what that little arrow means. Well, when I look up here at my actual graph, the left side of my graph it's going to continue to go up, but it's also moving out as it goes up. So it's going up and left. So we're going to continue to go left together, and whenever we continue and continue forever, we're never going to stop on this side. Let's go take a look at the right side. Same situation with the right side. We're going to continue out on the x-axis, but my actual graph is going up and out to the right forever. So this side of the graph is going to continue to get wider and go to the right. So when your graph continues forever in both directions, doesn't stop, you are going to use all real numbers. All real numbers. You can write it like this, or you can use the symbol that stands for all real numbers. Either one is okay with me. They both mean the same thing. And that's it. And actually, every single quadratic function that you're going to look at has a domain of all real numbers if there's arrows on the end. So if there's arrows on the end, it's always going to be that. Range is the little bit of tricky one. It's not going to be all real numbers every time. So range is our y values. So now we're looking at the y-axis right here. So I want you to take another highlighter, preferably a different color if you have one, and I want you to highlight where the vertex is, because that's where your graph actually starts. A graph that looks like this starts at the vertex. So there's our vertex. It's at 0, which we already know that. We are going to use all of the numbers that are greater than 0. And the reason why I know we're going to use the ones that are greater is because my graph is above the little yellow line that I just drew. And my graph opens up, which means it's going to be greater than. So here's how you would actually write it. It's going to look like y is greater than or equal to 0. The or equal to bar has to be there because it can actually be equal to 0. So we're going to include 0. And that's it for range. And that's actually it for all of the key features that we have to learn in Algebra 1. Okay, so now that we have talked about all of the key features, I want to do one more example with you before I let you practice some on your own. So flip to the inside. I would like to do example number 4 with you guys. So the good thing about these 4 examples on the inside, the graph is already done for you. So you are only focusing on identifying these important key features that we have to know. Okay? So we're going to start with vertex because remember, that's the most important point about these graphs. This vertex is right here. So I want you to put a dot on where that vertex actually sits. Now, my job is to find the ordered pair. Please remember that your x value comes first always. So the ordered pair for this vertex is going to be 4, and then I'm going to go up to 1. So my vertex is 4, 1. And your vertex, when you write it, has to be in parentheses. If it's not, then it's going to be counted wrong. So there's my vertex. It looks like it's going to be a maximum because this graph opens down, which is actually the next question. Since the graph opens down, it looks like a little mountain. So this is the max point of the mountain. Think about it like that. Okay, we're going to come back to axis of symmetry. Let's go down here to zeros. So remember, zeros are where does the graph cross the x-axis. So here's my x-axis right here. I'm wanting to know where does this graph cross the x-axis if it does. This graph does once right here and once right here. When you have a spot over here listed out, it's wanting to know what are the zeros. So you tell me the number at where it happens. So this one is 3 and that one's 5. And there you go. That's all you have to do for zeros. Now, just a quick little note. If you have a graph that looks like this, and it doesn't touch the x-axis at all because the x-axis is underneath it, there will be no zeros for this one. And you have to make sure that you write no zeros. So you do have an example of that in this foldable, so just be mindful of that. Okay, let's go back and get axis of symmetry. So axis of symmetry is the middle of the graph. What would cut this graph in half? So I'm going to draw my pink line. that shows the middle of the graph. And all I have to figure out is what number is that sitting at. And that's at 4. So the axis of symmetry is x equals 4. And there is a pattern, there is a relationship between the axis of symmetry and your vertex. These numbers are always going to be the same. So your axis of symmetry is always going to be the x value or the first number of your vertex. Every time. Because think about it, your vertex is sitting on the axis of symmetry, on the x value. Okay? Last two things, we got domain and range. So the domain, that's left and right, and this graph continues out forever, left and right. So it's going to be all real numbers. And then range, how you find range, here's a quick way. Take your highlighter, start at the vertex, and we're talking about y values here, so draw a line back to the y-axis because that's going to tell you your y value. So I know that I'm dealing with 1. Now, the only thing I have left to decide is if I'm going to use everything greater than 1, which would be above, or if I'm going to use everything less than 1, which would be below. And since my graph opens down, I'm actually below. So my range is y is less than or equal to 1. And there you go. So now what I want you to do, now that you have example 4 done, I want you to take a couple of minutes and I want you to do the other 3 examples in this foldable. Once you get those done, then you can push play to get the correct answers. So that way you'll be set. Okay? I'll see you in a little bit. Okay, as promised, I'm going to show you the correct answers. So here's example 4. That one we did together. Here's 3. The only thing that I want to point out about example 3 is this graph actually does not cross the x-axis at all, so you have to make sure that you actually write out no zeros. We cannot use the number 0, so make sure you write it out. Okay, here's example 2. So the zeros were at 0 and 4. I know this graph looks a little bit weird, but that's the origin. And finally, here is example 1. So the zeros for example 1 were at 2 and 4. And I made sure to put little dots so that I could easily see them and identify them. And there you go. I really hope that key features were easier this second time around. We are going to continue to work on them, so if you're still struggling, I've got you. Don't freak out on me just yet. But you guys did really good today, and I'll see you next time.